So I'm going to start recording. So we have, what we're doing is we've been dealing with forces and dealing with reactions to our structures. So this is a loaded structure and we have our points at reaction A and B. I do encourage you all to go into your textbook and look at the different connectors, because this textbook is the absolute best at doing the diagrams for the different connectors. Okay, it really is exceptional. So that one's great. So we've got our structure here, and we've got a loaded structure, and you can see the loaded structure. So one of the first things when we start looking at our structures is you want to do your free body diagrams. Now, this one, of course, we can do a couple of different ways, right? Because we've got a loaded structure, and so we can take our loaded structure and we can do this, and we can calculate the load associated with the rectangle. So if I look at that load with the rectangle, oops, when I wrote this, I didn't write it correctly. It's Newton meters, so I can do my 600 Newton meters times my 6 meters, which will give me the load for that part. And if you do that, it's what's 3,600, right? 6 times 600, 3,600. This will be 3,600 newtons. And we know where that is because it's an even distribution. This is one of those cases where don't kill yourselves. Use symmetry to your advantage, okay? And we know where that load is going to be, right? We know where that load is going to end up. We also know that this one, when we calculate it, it's going to be 1/2 300 times 3 for that load, because that's a triangle, right? That's a triangle. And if we do that one, that's going to be 900 divided by 2, should be 450 or 4,500. Let's do it. 3 times 300 divided by 2. I was right. It's 450. I was right first time. 450 newtons. Now, if you have your FE manual or the appendix in the back of the book or several other things, right? We know where the center of mass of triangle is. I've got a triangle that's evenly distributed. The center of mass is right here. So if this side is 3, this side is going to be 2 meters, and this side is going to be 1 meter. And you can actually look those up during the CRC handbook for math tables. You can go out and Google it. You can remember it from geometry. Speaking of which, I had to help an 8th grade do the interior angles of a whole bunch of different polygons over the weekend. More entertaining things to do this weekend. So we had that. So I've got my structures. So now let's look at our free body diagram. So how I do a lot of these is the author will say, draw an outline of your objects, but that's, just depends on what you want. So I have my objects here. This is A and B. This one, we know we're going to be only down. This one is a point. So this one, I do have a BX and I have a BY because I have a pin at that spot. Now, if you guess wrong, right? If we guess wrong, all it's going to do is tell us we have a negative. So, but if I have an A reaction, there's my AY. So I have my AY, I got my BY, I got my BX. I now have this one, and this one is my 450 Newton load that's going down. And then I have my other one that's going down and that's the 3600. This one is at 3. This one is at 2, and this is at 1. Now I drew that so I have my drawing in the right place. Now, this problem did not give you, we're ignoring the weight of our item, or we're assuming that the weight of the item is within the load that they give us, because they aren't giving us anything extra. So if we want to find the reaction, we can do it a number of different ways, but we're going to actually use our moments to do it. So I'm going to do, for our reaction at B, I'm going to sit at B. And we've got our A here. So I'm going to end up, so if I do the moment about B, that's got to equal 0. I'm going to have my AY times 6, because I'm 6 meters away. And it's going that direction. So guess what? It's got to be negative, because remember, this way is negative, this way is positive. And since I've got it going up, I'm rotating this way, and so that's going to be negative. So the other is my 450 newtons, and it's at 5 away from B. And then my 3600 is at 3 away from B. So I can solve for AY. AY is going to be 1/6 of times 5. 22 plus 10,800, and that's in Newton meters divided by meters. So I'm in newtons, so life is good. And I get 2175 newtons. Got that one, so that's great. We know the other fun part is we could probably do BX by inspection. There are no other forces in the X direction, so that's got to be 0. So we got the BX is 0. So now what we're going to do is we're going to do the moment about A. Got to be 0. So now my BY is going to go in the positive direction, so I get BY times 6. And then I have negative 450 times 1, and I have negative 3600 times 3. BY is going to equal 1/6. Oh, 450 plus I should have known it from the last one. Oh well. Five by 6. I get 1875 newtons. So kind of a nice way to look through our distributed loads and how to use what we already know, build on what we already know.